I'm Garrett Ryan. This is Told in Stone. Roman concrete redefined architecture. It allowed towering apartment blocks to rise with incredible speed. It made breakwaters that defied the waves. It supported the colossal vaults of the imperial baths and the dome of the Pantheon. All of this was made possible by geological good luck. The landscape of west-central Italy is volcanic. Rome stands on thick deposits of tuff, a soft igneous rock laid down by prehistoric eruptions. Although Roman tuff is easily carved, as the excavators of the catacombs discovered, it is too soft and porous to serve as a good building stone. It carries, however, the seeds of an antidote. Pockets of the tuff around Rome contain pozzolana, a reddish, gravelly volcanic sand. By trial and error, Roman masons discovered that pozzolana made exceptionally strong mortar when added to water and lime. They began to experiment with a new way of building walls, combining pozzolana mortar with chunks of rubble, and so Roman concrete was born. Over the following centuries, Roman concrete was developed into an increasingly sophisticated building material. Unlike modern concrete, which is typically poured into forms, Roman concrete was troweled in thin layers over beds of aggregate. The composition of the aggregate could be varied to modify the strength and weight of the mixture. Foundations could be stiffened with chips of heavy basalt. Vaults and domes could be lightened with bits of ceramic, tuff, or pumice. Roman concrete owed its unique properties to the chemistry of pozzolana. Ordinary lime mortar hardens through contact with the carbon dioxide in air. Pozzolana, however, contains soluble silica and alumina, which react with lime to form exceptionally stable bonds that can consolidate without exposure to air, even underwater. Seawater, in fact, makes the mixture even stronger. Since Roman concrete was not reinforced, it tended to crack and fail under tension. But its compressive strength, that is, its capacity to carry loads, is equal to that of good modern concrete. And thanks to its distinctive chemistry, Roman concrete is far more durable than most modern varieties made with Portland cement. The maritime variety compares favorably with even the most resilient building stones. So would it be possible, theoretically, to build a skyscraper with Roman concrete? The Romans themselves never contemplated such a thing. Although they used concrete in very tall structures, like the Pantheon and the reception rooms of Domitian's palace, these were nothing like modern skyscrapers. The closest equivalents would be the Insulae, apartment buildings that lined Rome's streets, and these were limited, at least officially, to a height of only 70 feet. In a world without elevators or reliable indoor plumbing, there was no incentive to make residential structures higher. Nor, in an economy without large corporations, was there any commercial impetus. Let's imagine, however, that a modern developer with more money than sense wanted to build a skyscraper in an American city, using only Roman building materials. Let's assume that the dimensions of this hypothetical skyscraper would be identical to those of Chicago's Monadnock building, the tallest commercial structure ever built completely of masonry. The north part of the Monadnock building, finished in 1891, is 215 feet tall. Originally, it was 274 feet long and 67 wide, covering half of a narrow city block. Could a skyscraper of that size be built using Roman concrete? The short answer is yes, but not cheaply or easily. There would be two basic methods of constructing such a building. One would use Roman concrete for both walls and floors, the other only for floors. Let's start with the all-concrete technique. This would make our hypothetical skyscraper a supersized version of a Roman insula, with walls of brick-faced concrete and floors supported by concrete vaults. The walls would have to be thicker than those of the Monadnock building, which are 6 feet through at the base, and might even approach the 20-foot thickness of the Pantheon's rotunda. Although chambers could be built into that masonry hulk, any windows would be reduced to tiny slits. Huge masses of Roman concrete, like those in the walls of the Pantheon, dried slowly and tended to deform under pressure. Although concrete walls on the scale of the Monadnock buildings could be built, they would take a very long time to dry and might develop dangerous cracks in the process. A much more achievable way to build a skyscraper with Roman methods would reserve concrete for the floors and make the walls from stone blocks. This was a technique used to construct the Colosseum, whose perimeter wall, at about 160 feet, was nearly as tall as our hypothetical building. The Lighthouse of Alexandria, another masonry structure, is thought to have been well over 300 feet tall. The walls of the Colosseum were made of huge travertine blocks, some more than 7 feet long. Though vulnerable to fire, which causes it to fracture, travertine is an exceptionally strong and weather-resistant stone, which could easily support a skyscraper. Despite 19 centuries of earthquakes and medieval pilfering of the iron clamps that held the blocks together, the north side of the Colosseum still stands to its original height. The Colosseum's stairs and seats were supported by concrete vaults. Similar vaults were sometimes used in the upper stories of Roman apartment buildings, and there would have been no technical problem in making the floors of a Monadnock building-sized skyscraper from 3 or 4 parallel vaults, especially if the concrete was lightened, as it was in the Colosseum, by using pumice as an aggregate. Despite the fact that Roman concrete was unreinforced, Roman builders sometimes used it to create floor slabs with spans of up to 20 feet. Leaving aside the question of whether these would pass a modern building inspection, using such slabs in our skyscraper would allow the builders to make the walls thinner, since they would no longer have to tolerate the lateral thrust of the floor vaults. It's hard to imagine, however, that the walls would ever be much thinner than the Colosseum's, which are 11 feet thick at the base. It would, in short, be possible to build a skyscraper with Roman concrete and Roman building materials. Such a building would be immensely strong and far more durable than any modern steel-framed structure. But it would be time-consuming and expensive to build, and its castle-like interior would be cramped and poorly lit. There are practical modern applications for Roman concrete. It could still be used, for example, to make cost-effective and extremely durable piers and breakwaters. But attempting to build a skyscraper with Roman concrete would be a case of applying one era's methods to another era's problems. An answer, but not the solution. I hope you enjoyed today's video. For my new Roman Review video and other exciting content, check out the Toll & Stone Patreon, linked on screen and in the description. Thanks for watching.